In a previous video titled SmartNICs at 100G and the von Neumann bottleneck, I covered at a high level how the DDR4 memory system of an ARM core-based SmartNIC would become the performance bottleneck for the SmartNIC. In that video, I used 100% bandwidth as an example. Since then, my friend Nick asked why I mixed bits and bytes and suggested that I do the whole thing in bits and look at using a more realistic 50% utilization model. He's my SmartNIC. I know, corny. Today we'll dive down again into the 100% traffic model, making some suitable assumptions. Then more realistically, we'll look at a 50% traffic utilization model, and finally a balanced model based on the available DDR4 3200 SmartNIC memory bandwidth. It should be noted that we're assuming all NIC traffic is going through the DDR4 memory system, so the ARM and encryption cores can add value. It is possible that packets can bypass this complex, but then what is the point of buying a SmartNIC or a DPU? This 100% utilization animation shows that the DDR4 memory system at 3200 megatransactions per second works out to 204.8 gigabits per second, so we'll call it 205. Everything will be in gigabits per second from here on out. Assuming a dual socket server with a bifurcated SmartNIC, which means that the SmartNIC's PCIe bus is evenly split between both sockets, results in memory demand of 200 gigabits per CPU. We also have two 100G network interfaces that each generate 200 gigabits per second of bidirectional memory access. So this is 800 gigabits per second of memory bandwidth for I/O. All this I/O needs to be processed. This means that at least another 800 gigabits per second is required for the ARM cores in the data plane to read the packets and determine what to do with them. This takes us to the 1600 gigabit per second range. Now, assuming 1/10 of the traffic is encrypted, these modules need to access memory, also adding another 80 gigabits per second of memory bandwidth. So in total, worst case, the ARM core SmartNIC at 100% utilization demands 1680 gigabits per second of bandwidth from a memory system that can only provide 205 gigabits per second. This means that the memory subsystem is 8-to-1 oversubscribed. Now this assumes that all SmartNIC data must flow through the DDR4 memory, which may be required for SmartNIC managing traffic in a virtual network environment where nearly every packet is encapsulated. Now this is the worst case. As my friend Nick suggested, if we drop down to a more realistic 50% utilization model, things improve, as shown in this somewhat faster animation. Still, the system is 4-to-1 oversubscribed. Also, it should be pointed out that each ARM core would be required to completely process 50 gigabits per second of traffic, averaging 16 bits per clock tick, assuming a 3 gigahertz ARM core. This is entirely unrealistic. If we now focus on the real problem, the DDR4 3200 memory bandwidth at 205 gigabits per second, and balance everything around that, we get the following diagram. Note that this is at a 12.5% overall SmartNIC port utilization. This translates to 15 gigabits per second per ARM core, or 5 bits per ARM CPU clock tick at 3 gigahertz. This is 6 clock ticks to fully process something like 32 bits of network bandwidth, which is approaching what might be possible given that the ARM core should be unwrapping virtualized network packets, then routing them. So this performance level may still be very hard to achieve. As mentioned earlier, the Ethernet block on the SmartNIC could bypass the DDR4 memory and route packets directly to the DMA block, then onto the host to achieve bandwidth rates approaching 100 gigabits per second. Also, the DMA block should be able to route packets to the network interfaces without going through DDR4. But then, what's the purpose of having ARM cores, or for that matter, calling it a SmartNIC? Hopefully, this has clarified how utilizing ARM cores in the data plane for normal traffic isn't an ideal SmartNIC solution. Other memory systems and architectures exist that are substantially faster, and we'll talk about those in upcoming videos. Thank you for your time.